Imagine using the sun's power to light up your life, save on energy bills, and contribute to a cleaner planet. Solar modules, the key technology behind solar energy, play a pivotal role in this transformation. But do you know how a solar module is made and how it works? Today, we'll walk through every step of its journey, from the raw materials to installation, highlighting why each phase is so critical. By the end, you'll see how every detail, from the purity of silicon to the precision of installation, makes solar energy the powerful force it is today. The journey of a solar module starts with metallurgical grade silicon, MGS, which is the primary raw material for the creation of solar grade silicon. MGS is derived from quartz, a naturally abundant mineral, and processed in electric arc furnaces. At this stage, the silicon is about 98–99% pure. To use it for solar cells, it must undergo further refinement to reach solar-grade silicon, which is 99.9999% pure. This is done through a method called the Siemens process, where the MGS is combined with a chemical compound like hydrochloric acid to remove impurities. Why it's important? Silicon purity is the foundation for solar cell efficiency. The higher the purity of the silicon, the more effectively the solar cells can convert sunlight into electricity. Without this high purity silicon, we wouldn't have the efficient, long-lasting solar panels we rely on. Once purified, the silicon is formed into cylindrical ingots using a process known as the Czochralski method, where the silicon is melted and a seed crystal is pulled from the melt to form a large single crystal. These ingots are then sliced into thin wafers, typically about 180–200 micrometers thick. These thin wafers are what eventually become solar cells. Why it's important? The thickness and quality of the wafers are critical. Thin wafers allow for better material utilization, while precision in the slicing process minimizes waste and imperfections, which can lead to decreased efficiency. Any defects in the wafers at this stage can reduce the overall performance of the solar panel. Next, the silicon wafers are turned into solar cells. This involves a process called doping, where the wafers are treated with small amounts of other elements such as phosphorus, which adds electrons to create a negatively charged layer, and boron, which creates a positively charged layer. This forms the p-n junction that is essential for photovoltaic electricity generation. After doping, the cells are coated with a thin layer of anti-reflective coating to reduce energy loss due to reflected light. Next, metal contacts are added to the front and back of the solar cells to allow the electrical current to flow out. These contacts are typically made of silver for high conductivity. Why it's important? The efficiency of the solar cells depends on the quality of the p-n junction and the metal contacts. The doping process is what enables the cells to generate electricity from sunlight. Even small defects in this step can result in significant energy losses. After the solar cells are fabricated, they are connected together to form a solar module. In this stage, the cells are wired together in series or parallel to achieve the desired output voltage and current. The cells are then encapsulated in a layer of EVA, ethylene vinyl acetate, which is a transparent polymer that protects the cells from moisture, dust, and mechanical damage. The encapsulated cells are sandwiched between two layers of tempered glass for protection, and the backsheet, which is typically made of durable materials like Tedlar, ensures the module's longevity. The module is then framed in aluminum, which provides structural support and weather resistance. Why it's important? Proper encapsulation and framing are essential for ensuring the solar panel's durability. Without proper protection, environmental factors such as rain, snow, and UV exposure could degrade the performance of the solar cells. The aluminum frame ensures that the panel can withstand wind, snow loads, and other physical stresses. Before any solar module leaves the factory, it undergoes a series of rigorous quality control tests to ensure that it meets both safety and performance standards. These tests include checking the module's electrical performance, confirming it meets global standards such as IEC 61215 for performance and UL 6173 for safety. Other tests simulate environmental conditions such as thermal cycling, damp heat, and UV exposure to ensure the module can withstand decades of real-world conditions. The modules are also subjected to visual inspections for defects such as microcracks or damaged cells. Why it's important. Quality control ensures that the modules are safe, reliable, and perform at their highest potential. Without these rigorous tests, we would risk widespread failures and lower overall efficiency in the field. Solar panels are designed to last 25 to 30 years, and testing ensures that they can indeed meet this long lifespan. After passing all the tests, solar modules are carefully packed and shipped to distributors, installers, or directly to consumers. Packaging is critical to prevent damage during transit. Each panel is wrapped in materials designed to protect it from environmental hazards such as moisture, dust, and physical shocks. Why it's important. Safe transportation ensures that the panels arrive intact and ready for installation. Improper handling can lead to damaged cells, which would affect the panel's performance. It's crucial that modules are protected from potential harm during this step to maintain the high quality achieved during manufacturing. Finally, the modules are installed. The installation process begins with a proper assessment of the site. Whether it's a residential roof, a commercial building, or a large solar farm, the modules are mounted at the optimal angle to maximize exposure to sunlight. The modules are connected to an inverter, which converts the direct current, DC power produced by the panels into alternating current, AC power, which is usable by household appliances. The system may also be connected to the grid to allow excess power to be sent back, or in some cases, energy is stored in batteries. Why it's important. Proper installation is critical for the system to operate efficiently. Panels must be positioned to minimize shading, maximize sun exposure, and ensure the electrical connections are secure. Additionally, ensuring that the system is properly connected to the grid or battery storage ensures that homeowners and businesses can take full advantage of the solar power they generate. So there you have it. The journey of a solar module from raw material to fully functional energy source. From the high purity silicon that powers the cells to the rigorous testing that ensures quality and longevity, every step is designed to maximize efficiency and reliability. The power of solar energy is built on precision, innovation, and sustainability. So the next time you see a solar panel, you'll know the story behind it, the dedication and expertise it took to bring clean energy to your home or business. Thank you for taking this journey with me. The future is bright and it's solar powered.